First off, we got some two-way tables, and I've got to fill in some blanks in this table. I see that the first row is almost complete. We've got 72 in total. Minus 12 is going to be 60. Minus 25 is going to be 35. Minus 11 would be 14. For the next row, I'm only missing one also. 65 minus 11 is 54. Minus 25 is going to be 34, 29. And minus 15 is going to be 14 again. And then I might go after some of the other stuff. I'm going to go for this column just because I see what's going on here. So we got 11, 25, 50, 61. And then over here, we've got 46 total. Minus 22 is going to be 24. Minus 14 is going to be 10. And which is totally not right because I added stuff wrong here. That should be 24. And that should be 0. Okay, that's better. All right, going backwards here, we've got 58. Minus 25 is going to be 33. Minus 10 more, 23. 14. And then here we got 40, 51, 65. Just to make sure that things add up okay. Oh man, I missed one. Whew. I missed 2. What's going on? So this is 78 minus 10 is going to be 68. Minus 9 is going to be 59. Minus 20 is going to be 39. Minus 5 is 34. Minus 12 is going to be 22. 11, 22 is 33. Plus another 22 is 55. And just to make sure things add up okay, we've got 65 plus 78 plus 61 plus 46, which gets me to 250. Now going down the total column, 672 plus 65 plus 55 plus 58 gives me 250 both ways. All right, next up we got to use the table. How many students are in 12th grade and have just twigs? So I'm looking for students in 12th grade with only twigs. We got 19. What is the probability that a randomly selected student has only rocks? So we want the total with only rocks. Divide by the total number. So that's going to be 65 out of 250. Moving on. What's the probability that a random student in 11th grade has only rocks? So now we're limiting ourselves to only 11th grade, and we're looking at the probability that they have just rocks, which would be 11 divided by 55. What's the probability that a student selected is in 9th grade or has only rocks? So in 9th grade, that's going to be looking at the total there, or has only rocks. We've got to add the other rocks categories that are not 9th grade. So we've got 72 plus 15 is going to be 87, plus 11 is going to be 98, plus 14 is going to be 112. So 112 divided by 250. And then finally we've got to find, using probability notation, P of both given 9th grade. That's how we read that. So we look at 9th grade first, and then we look at our both columns. So it's 11, and that's probability of both given 9th grade. And then the other way of looking at this is probability of 9th grade given both. I'm going to start off with my both column, and here we've got 11 out of 61. And that means the probability of being in 9th grade, given that this person has both rocks and twigs. Here we have another two-way table. Let's start by filling in this table. I see in the first row, we're trying to get to 103, and I've got 27 and 32. That gives me 59. To get to 103 is going to be 44. In my first column, I've got 27, 25. We've got to get to 105. That gives me 52. 53 more would give me 105. Going across, we've got 55 plus 88 plus 99, 242. And then going down, we've got 181 minus 88 minus 44 is going to be 49. We've got 39 plus 99, and then minusing that from 199 is going to be 68. I'm just going to add across that row to make sure those add up. 25 plus 49 plus 68. I get 142. And then if I'm going to add across the bottom, 105 plus 181 plus 199 gives me 485. And if I did everything correctly, if I add down that last column, I should get the same thing. So if I do 142, 242, and 103, I get -2. So something went wrong there, and I've got to figure out what happened. Looks like here I added up wrong. This should be 240 and not 242. That gives me 45. Cool, we're good. Okay, let's find these probabilities. Employee has a low joker toxin level. So we're talking about this. That's really going after this. So 103 over 485. An employee has a normal joker toxin level and is 30 to 49. So that's this specific element. We got 88 out of 485. An employee is under 30. So that's 105 out of 485. I'm going to zoom out to keep going. An employee has a high joker toxin level given that they are over 50. So given that they are over 50, I'm going to look only at this column, and has a high level. We're looking at 68 over 199. An employee is over 50 and has a high joker toxin level. That's looking at this, but this time is out of the entire thing. So we're looking at 68 over 485. An employee has a normal joker toxin level or is 30 to 49. So we're talking about this column and this column. I'm going to take this 240 number, and to that I'm going to add the two parts of this column that are not also on the normal level. So it's plus 44 plus 49, and I get 333 out of 485. As an employee is under 30, given that they have a high joker toxin level. So we're looking at the high joker toxin level and under 30. So 25 out of 142. An employee that is 30 to 49 has, so we're only looking at this column, has a normal joker toxin level, and we're looking at the 88 part of this. So 88 out of 181. All right, find the probability under 30 given low joker toxin level. I'm going to use yellow for this. So given low joker toxin level, this is going to be out of 103. Under 30 is 27. And for the other part of this, I'm going to use purple. And that's low joker toxin level given under 30. So now I'm going to look at this column. This is going to be out of 105. And we're looking at 27 out of that. So 27 out of 105. Here we are looking at some standard deviation stuff, and we've got to think about this in terms of our empirical curve. By that I mean empirical rule on the normal curve. So we have our mean, and we're talking about this as like 1 SD out, 2 SDs out, and then we got a third standard deviation. And we talked about that between these purple lines we had 68%. Between these red lines we had 95%. And between the blue lines we have 99.7%. Okay, So we have 1,800 hover cars that were recorded. The mean level of awesome was 68. That's kind of annoying. Standard deviation of 7. So going up 1 and down 1, we're going to have 75, and we're going to have 61. Going up 1 more and down 1 more, we got 82 and 54. And then up 1 more and down 1 more, 89 and 47. All right, what percent of hover cars were between 61 and 75? Those are my pink zones. That's 1 standard deviation above and below. That's going to be 68%. What is the range for the middle 95%? That's going from red line to red line. So 54 to 82 Oz. For awesomeness for the middle 97%, that's going from blue to blue, or 99.7 rather. That's going from 47 through 89 Oz. And then what percent of hover cars were more awesome than 75 Oz? 75 is here. If I think about this as in the mean is going to be 50%. And then here we've got 34%. That gives me 84% below, which means we've got 16% above. And then 82 Oz. We've got, again, 50% below. We've got 34% here. And then going from 68 to 95 is going to be 27. So half of 27 would be 13.5%. And that would end up giving me, I can't think right now, 84 plus 13.5 is going to be 97.5. All right. Second problem, we got honey badgers living in Portland, Oregon. Here's our mean, which was 1750. And then standard deviation of 450. Going up 1 is going to be 22, down 1 is going to be 13. Going up 2 and down 2 is going to be 2650. And 9, 850. And up 3 and down 3 is going to be 31 and 4. All right, between 13 and 22, that's 68%. And we know that because of our empirical rule. Earned more than 2650. Well, we know this is going to be, let me do this in pink, are 95%. I'm going to do this in a little different way than I did above. That means between the two outsides, we have 5% left. To make that happen, we got 2.5% at the bottom, 2.5% on the top. That means that if we're talking about earning more, 2.5%. The range of salaries for the middle 99.7%. We're going out to our green numbers. That's going from 4 to 31 buckaroos. Next up, we've got some sampling questions. Here we have to make some different things between, we have to differentiate between samples and populations, and we have to make a confidence interval. Okay, so the population, that's everything that we're looking at, not just the population that's answering things. So the population, we talk about people currently living in Massachusetts. So currently living in MA. All right, and then we're asking what's the sample. That's going to be 400 current residents, the people that we're actually having do the survey. Determine 95% confidence interval. So we are given a margin of error here, and we're given a 38.6% have lived in Massachusetts. I'm going to figure out that my interval is going to be 38.6 minus 4.8%, and that's going to give me a value of 38.6 minus 4 is 34.6 minus 0.8 is going to be 33.8%. And then if we add 4.8, so 38.6 plus 4.8, we got 42.6, 42, 43.4. And then interpreting that, we can be 95% certain the true, I'm going to not write everything all the way out, the true percent of people living in Massachusetts that have lived there their entire life is between 33.8 and 43.4%. All right, number 6, we've got a survey thinking about pickles being the best food ever. The population scenario is all DHS students. The sample are those that were selected for this. So 250 students sampled. And then 95% confidence interval, we're given a margin of error. We've got to figure out of 250, 182, so I got to find the percent for that because my margin of error is in percent. 182 out of 250. When I do that calculation, 182 divided by 250, I get 0.728, so that's 72.8%. Then we're going to add, subtract 5.52%. That gives us, on the lower end, we're talking about 67.3, 67.28, 67.28%, and on the higher end, we've got 72.8, 77.8, 78.32. To interpret this, we can say something like, we are 95% certain the true percent of pickle lovers is between 67.28 and 78.32. That is what we mean by interpreting this. All right, next we got some trigonometry stuff. For 7, we got to find the length of each of these sides. Knowing this angle, I'm going to label my sides as opposite, hypotenuse, and adjacent. Knowing the hypotenuse and wanting the adjacent, this is a cosine. So we got cosine of 57 is equal to x over 15. 15 cosine of 57 is equal to x. And if I were to want to do that out, 15 cosine of 57, I get 8.16. Looking at number B, we know this angle is 44. Here we've got opposite, hypotenuse, and adjacent. This is a sine problem, so sine 44 is equal to x over 5. 5 sine 44 is equal to x. When I do that, Bell's going to ring in a second. Sorry about that. 5 times sine 44. We get 3.47. All right, so identifying the angle is 73 degrees, our opposite, hypotenuse, and adjacent. Here we're going to be using tangent, so we got tan 73 is equal to 15 over x. To get the x out of the denominator, I've got to multiply both sides by x. We get x times tangent of 73 is equal to 15. And then we've got x is equal to 15 divided by tangent of 73, which is equal to 4.585. Looking at number 8, we're solving for some angles. Here we've got angle A we're looking for. Here's my opposite, my hypotenuse, and my adjacent. I see an O and an A, so I'm going to use tangent. Tangent of theta is equal to 11 over 10. That means that tangent inverse of 11 over 10 is going to be my angle. And if you want to do that on a calculator, instead of leaving that as is, we're looking at 11 over 10 inside of tangent inverse, and we get an angle of 47.726 degrees. For number B, here we're looking for B. For B, that's kind of fun. And I've got my opposite, my adjacent, and my hypotenuse, O and A again. This is also going to be tangent. So tangent of theta is equal to 15 over 5. Tangent inverse of 15 over 5 is going to be my angle. And again, if you choose to go further and get a decimal for this, 15 divided by 5, we're looking at theta is equal to 71.56 degrees. For number C, here we're looking for A. Going straight across, I got my opposite. Across from the right angle is my hypotenuse. And then we've got my adjacent right there. Here we've got opposite and hypotenuse. So we've got sine of theta is equal to 5 over 16. Sine inverse of 5 over 16 is equal to my angle. And if we get a decimal for that, 5 divided by 16, we get theta is equal to 18.209 degrees. Cool. Looking at number 9, we're going to have to find the value of each trig ratio. Cotangent, I know, is the reciprocal of tangent, which is opposite over adjacent. And if I label my triangle, here we've got our opposite, our hypotenuse, and our adjacent. So tangent of theta would be the opposite. Oh man, I don't even have that yet. I got to Pythagorize to get the third side. So that would be 13 squared is equal to 5 squared plus x squared. That's going to give me x is equal to 12. Okay, back to this part. So we've got opposite over adjacent is 12 over 5. That means that cotangent of theta is going to be equal to 5 over 12. That is the end of this problem. You're not asked to find an angle. All right, secant of theta. Secant goes with cosine, and cosine is going to be adjacent over hypotenuse. Let's label some stuff. Here we've got our opposite, our hypotenuse, and our adjacent. We don't have adjacent yet, so let's figure that out. I'm going to Pythagorize again. We got 15 squared is equal to 2 square roots of 14 squared plus x squared for that other side. And we do that, we got 225 is equal to 4 times 14, which is going to be 56, plus x squared. All right. 225 minus 56 gives me 169 is equal to x squared. X would be 13 based on that. All right, so now let's find cosine. Is going to be adjacent over hypotenuse, 13 over 15. And then we've got secant of theta is equal to 15 over 13. It's the reciprocal. We know it's secant because cosine and secant go together. They go with the wrong letter. For C, we're finding cosecant. Cosecant goes with sine of theta. All right, based on this, we've got our opposite, our adjacent. We don't have our hypotenuse yet, so let's Pythagorize. 5 squared plus 10 squared is equal to x squared. So we got 125 is equal to x squared. X is equal to the square root of 125. sine of that, so sine of theta would be 5 over root 125. We could simplify that, but we don't need to. And if I find cosecant from that, we get the square root of 125 over 5. For number D, we've got cosine of theta. Here we've got our opposite, our hypotenuse, and our adjacent. We need adjacent over hypotenuse, so we're going to Pythagorize. 15 squared minus 12 squared is equal to x squared. That's 225 minus 144 is equal to x squared. 225 minus 144. We end up at 81. That means that x is equal to 9. All right, cosine is adjacent over hypotenuse. So cosine theta is equal to 9 over 15. For number E, we're looking for cosecant. That goes with sine of theta because it's the wrong letter. And here we've got our angle, our opposite, and our hypotenuse. Oh, that's so nice. First one we don't actually have to Pythagorize. Sine of theta is equal to 7 over 25. That means that cosecant of theta is equal to 25 over 7. Next up, we've got some law of sines and law of cosines things. We can use law of sines and law of cosines here, or we should use them because we do not have things that we know are right triangles. Looking at our first one, I've got an opposite angle and pair for side C. That's really cool. That tells me that law of sines is going to be my best bet. So I'm going to begin by setting this up, and we're trying to solve for angle B. So I'm going to use that as my other pair. And in doing that, so it's going for B and 23 there. So sine B over 23 is equal to, I'm going to use the same colors, sine of C, which is 126 degrees, over 52. I'm going to get sine B by itself by multiplying by 23. So I get 23 times sine of 126 over 52. Doing that out, 23 times sine of 126 divided by 52. We end up as sine of B is equal to 0.3578. We know to get the angle by itself, we have to use inverse trig. So let us do sine inverse of 0.3578. And when I do that, sine inverse, we end up at B is equal to 20.9672 degrees. All right, looking at B, we're finding side AB, so I'm just going to put an X there. And here we've got, we do have a 90-degree angle. We don't actually have to use law of sines or law of cosines there, so I could end up doing that. The other piece that I have as far as a side is that 30, but I don't know what that angle A is. But I do have two of these angles, and I know that they have to add up to 180. So we've got 90, so I've got 90 left over, and 43 plus 47 would give me 90 degrees. Okay, so now I have enough stuff. I can use law of sines for this. Here we've got sine of 47 over 30 is equal to sine of 90 over x. All right, sine of 47 over 30, I'm just going to do that as a decimal. And do that a slightly different way than we did the last one. And when I do that, I get 0.0243 is equal to sine of 90 is 1 over x. I'm going to multiply both sides by x. And when I do that, we get 0.0243 is equal to 1. Okay. I've got to divide by that 0.0243. And we get x is equal to 1 divided by that. And that gives us 41.0198-ish. All right, number C. Here we've got finding AC, and we've got an opposite pair, so we are in good shape for the law of sines. I'm going to use angle B with a question mark. So we've got sine of 17 over that question mark is equal to sine of 143 over 37. And I don't know about you, but I'm feeling kind of sassy. And instead of doing this problem the same way we just did the previous one, I'm going to reciprocal both sides and rewrite this as question mark over sine of 17 is equal to sine of 143 over 37. What this does is it saves me a step, because if I multiply both sides by sine of 17 to get that out of the denominator, I'm left with just what I was looking for, which is just that question mark. So I can literally type this into my calculator now. Sine of 143 divide by 37 times sine of 17. And when I do that, I also like that I totally started to do the reciprocal of one side, but not the other side. So let's go back to this step, because I was getting a weird decimal answer. Notice that. So we've got question mark over sine of 17 is equal to 37 over sine of 143. This is a good example of it. You can't reciprocal one side without doing the other side too. Totally did that on purpose. So if we do question mark then is equal to 37 over sine of 143 multiplied by sine of 17. I'm going to give myself a little bit more room. We end up getting a value of the question mark is equal to 17.97521, which is way better. Oh, that's supposed to be centimeters, I guess. It's way better than the decimal answer I was getting. It was like 0.21, and I was like, no! All right. Moving up to number 11. We've got to find BC. So that's up here. And I don't have enough for that. Okay, I don't have two parts for angle B and side B. Oh man, I don't have C either. Because I don't have any of that, I've got to use the law of cosines. All right, so what I'm looking for is that side and the angle that's opposite it. Since we're looking at A, that's the law of cosines is going to set up. So A squared is equal to one of the sides, let's call that 28 squared, plus the other side, let's call that 15 squared, minus 2 times 28 times 15 times cosine, and angle A is going to be 110. All right, beauty of law of cosines is once I have the setup, I can literally type this onto a calculator. So we get 28 squared plus 15 squared minus 2 times 28 times 15 times cosine of 110. And doing that, I get 1296.2969. If I square root both sides, we get A is 36.0041. All right, moving downwards. Here we're solving for BC, and that's going to be A again. All right, I don't have any opposites. If I try to find stuff, nothing works out. Therefore, I'm going to use law of cosines again. I'm looking for A, so I'm going to set this up as an A squared law of cosines. We've got 18 squared plus 19 squared minus 2 times 18 times 19 times cosine of the angle that's opposite that, which is 114. And again, as soon as I do that, I can start calculating. So we've got 18 squared plus 19 squared minus 2 times 18 times 19 times cosine of 114. Doing that, I've got a squared is equal to 963.2078. If I square root stuff, we end up getting A is equal to 31.03559. Next up, we're doing some converting from radians to degrees and from degrees to radians. I'm going to do these both in terms of conversion factors and in terms of setting up proportions. So, looking at my first one, we've got 23 pi over 12. I'm going to use the idea that a half circle is equal to pi and that a half circle is also equal to 180 degrees. Since I want to get rid of the pi, I'm going to put pi on the bottom and 180 degrees on top. And when I do that, my pi's cancel out. And I can also reduce 180 over 12 is going to be equal to 15. So I'm going to try to cross-cancel as much as possible ahead of time. So then if I've got 23 times 15, we end up at 345 degrees. Looking at B, I'm going to do this in terms of ratios. So whatever this angle is in degrees, so negative pi over 18, so I'm going to do that over pi is equal to some number over 180. I know from this that when I'm dividing, it's the same as multiplying by the reciprocal. Those cancel out, and I end up with x over 180. So we've got negative 1 over 18 is equal to x over 180. Multiplying both sides by 180, we get x is equal to negative 10 degrees. For C, I'm going to go back to a conversion factor. I'm trying to get rid of the pi, so we end up with pi on the bottom, 180 on the top. And in doing so, we can divide that by 6 and get 30 over 6. Divide again and get 5. Okay, my pi's cancel out. 61 times 5 is going to be 305 degrees. 29 pi over 6 I'm going to do as a proportion. So negative 29 pi over 6 divided by pi is equal to some degrees divided by 180. Awesome. I'm going to cancel out my pi's because we saw we could do that before. And we get 29 over 6 negative is equal to x over 180. I'm going to multiply this to the other side, and the 186 is going to reduce to 30, so we get negative 29 times 30, which is negative 780 degrees. Going the other way, I'm going to do the same thing and kind of mix and match these as conversion factors or proportions. We've got times pi over 180, because I know I've got to get rid of the degrees now. This does not reduce particularly well. So I'm just going to plug this in. 535 divided by 180. Both are divisible by 5, but that's going to give me 107 over 36. And then pi. For 1050, we're going to set this up as a proportion. So 1050 divided by 180 is equal to some radians over pi. 1050 over 180, the first thing I notice is that I can reduce there, and I don't think that reduces any further. Oh, no, I can reduce that by 3 and get 35 over 6. Multiply the pi to both sides, and I get 35 pi over 6. For number C, we're going to multiply this by pi divided by 180. Both of these are divisible by 5. So in doing so, we end up getting 5 is going to be 15, and 180 divided by 5 is going to be 20 plus 16 more, 36. Both those are divisible by 3. We get negative 5 pi over 12. For negative 195, I'm going to use my proportions again. So we got that over 180 is equal to x over pi. Negative 195 divided by 180. Okay, on the bottom that would be 36. On the top that would be 36 plus 3 more is 39. Move the pi to this side. I can reduce that to 13 pi over 12 is equal to x. All right, number 14, we've got to find the value of the trig function given the stuff that we have. So I've got negative 8 comma 17. Let's angle that up and make this a triangle by drawing to the x-axis. We have to use the x-axis. So we got negative 8 square root of 17. For sine, I need the opposite divided by the hypotenuse, because that's the angle I'm looking at. So I do need that hypotenuse, and if we do negative 8 squared plus root 17 squared is equal to that hypotenuse squared, we get 64 plus 17, which happens to be 81. Hypotenuse is going to be 9. All right, sine is opposite divided by hypotenuse, would be the square root of 17 divided by 9. Looking at B, we're looking for cotangent. And in drawing my triangle, I've got sides root 13 and negative 6. Not 16, 6. All right, I know that cotangent is the reciprocal of tangent. So let's find tangent of this angle. Tangent is opposite over adjacent. So that's negative 6 over root 13. That means that my friend the cotangent is going to be root 13 over negative 6. And I wrote 16 again. I like how I wrote that as root 6, but that's going to be negative 6. All right, looking at number 15a, we're finding the reference angle for this. And that means we're trying to figure out what to get back to the closest x-axis. For 29 pi over 9, going around one whole time is 2 pi, and I'm going to write that in terms of a denominator of 9, so that'd be 18 pi over 9. Going around another half would be an extra pi, and that would give me another 9 pi over 9, which is 27 pi over 9. And that leaves me with just this small piece here. And to get from 27 to 29, it's going to be 2 more pi's over 9. For D, we're looking at negative 65 over 18. And we do the same thing that we just did. And we're trying to figure out what this angle would be. Going around one whole time would be 2 pi, which is going to be negative 36 pi over 18. Adding in an extra half is going to be an additional pi, so that's going to be another 18 pi over 18, which takes me to negative 54 pi. Adding an extra quarter beyond that. Actually, you know what? Let's just go to this whole half thing again. So adding another pi would take us to negative 64, negative 72 pi. To get from 72 to 65 is going to be 7 pi over 18. And the last one of these, looking at 49 pi over 18, going around a whole time is going to be 36 pi. We already said going around 1.5 would be 54 pi over 18. And if we're looking for what it would take to get to that, to get from 49 to 54, we need 5 more pi. And that would be our reference angle. Next up, we've got graphing some trig stuff. I'm going to start by trying to identify things that are useful to me. like the midline, which is going to be at a height of 2. And if I go 1, 2, I'm going to draw a nice line across just so I know what's going on there. And then if I look at my amplitude, that's -3, so I'm going to do two things. First is to draw a nice negative cosine shape. And then secondly, I'm going to go up 3, and then I'm going to go down 1, 2, 3. Okay, then I need to do some other stuff. I've got to figure out kind of a starting point and an ending point for my one period that I'm going to graph. So I'm going to take this inside, set it equal to 0. That gives me an x value of 0. That's going to be this first point here. All right, so that's on the bottom. And then I'm going to go with the inside. 2x is equal to 2 pi. I have to do 0 and 2 pi. Solving that, that's going to be x equals pi. And I'm going to call that pi. Exactly in the middle of 0 and pi is going to be pi over 2. And that's going to be at the top of my cycle. And then I'm going to go exactly halfway between these two. That's going to be at pi over 4. And exactly between pi over 2 and pi is going to be 3 pi over 4, 3/4. All right, nice smooth curve. Bada bing, bada bing, bada bing. And we have a graph. Next up, numero 18. We do the same thing. I'm going to start with my midline. This is at a height of 1. And then I'm going to look at my amplitude, which is 1, and go up 1 and down 1 from there. Again, I like making these nice lines so I can see what's going on. And for a graph of sine, I want to remind myself that it looks like this guy. Okay, now I'm ready for the inside stuff. So we're going to set the inside 1/2 x minus pi is equal to 0. I'm going to add pi to both sides. We get a 1/2 x is equal to pi, which means that x is equal to 2 pi. That's my starting point. So there's 2 pi. And then we do the same thing for my ending point. So a 1/2 x minus pi is equal to 2 pi. I've got a 1/2 x is equal to 3 pi. And then x would be 6 pi. So then here is going to be 6 pi. These are my two ending points. Well, first I've got my 0 and my 2 pi, and those turn into 2 pi and 6 pi. Exactly halfway between these two, I've got my lovely other midline point. 2 and 6 is 8, the average of which is 4, so that's going to be at 4 pi. Cutting in half again, we get 3 pi and 5 pi. So that's going to be the top, because that's what's going on there, and the bottom of my cycle. So a nice smooth curve, and we have sine. Number 17, because obviously I'm going out of order, and that makes sense. Same thing, we'll look at my midline of -1. There's -1, ba-da. Going to go with my amplitude of 2, 1, 2, and then 1, 2. See, you didn't know you were learning Spanish while taking this review video either. The more you know, ba-ba-ba-bum. Then we're going to start at the inside. 3x is equal to 0, which means that x is going to be 3 as our starting point. Sine, which looks something like this, is going to start us on the midline. So at 0, I'm going to be on my midline at a height of -1. And then I'm going to find my ending point. 3x is equal to 2 pi, which means x is equal to 2 pi over 3. That's also going to be on my midline. So if I mark that, we've got 2 pi over 3 here. Exactly in between these two is also going to be on the midline, and that's going to be exactly between 0 and 2 pi over 3, otherwise known as 1 pi over 3. Cutting each of these intervals in half again, between 0 and pi over 3, we've got pi over 6. That's going to be up top. And then between pi over 3, otherwise known as 2 pi over 6, and 2 pi over 3, otherwise known as 4 pi over 6, we end up getting 3 pi over 6, and that's going to end up giving us pi over 2. Woohoo! Sitting there at the bottom. A nice smooth curve connecting these beautiful, well-marked points. And we are donezo. And then finally, we've got cosine of the quantity 3x minus pi over 2, and then all minus 2. Same thing, start with the midline of minus 2. Da-da-da-da. I've got an amplitude of 1. I'm going to go 1 up and 1 down from there. Zap those across with my very clearly marked, that's definitely exactly 1 above that. And then same thing, start at the beginning. So 3x minus pi over 2 is equal to 0. Pi over 2 is going to be equal to 3x. And when I do some dividing, we get x is equal to pi over 6. That's actually not that place at all, because cosine looks like this. It's going to be the top point. Oof, that was almost embarrassing. All right, then we got 3x minus pi over 2 is equal to 2 pi. I know I've got to add the pi over 2 to this side, so maybe let's make this 4 pi over 2 so we have some common denominators. So when I add these two together, we get 3x is equal to 5 pi over 2. Dividing by 3 nets us x is equal to 5 pi over 6. That's also going to be at the top of my cycle. So you've got 5 pi over 6. Cutting these two in half again, so 1 plus 5 is going to be 6. Cut in half would give us 3 pi over 6, which you could write as pi over 2 if you'd like, but you don't have to reduce. And then we're looking at pi over 6 to 3 pi over 6. That's 4 divided by 2 gives us 2 pi over 6. And then between 3 and 5, we end up with 4 pi over 6. Nice smooth cosine curve. Looks a little bit like a reindeer. And we are done. Here we've got some trig modeling stuff. So we're going to start with a problem about a dirigible. So basically we got to find some information here. We got to figure out what the amplitude, phase shift, etc. is. Let's talk about the midline to start things off. And to do that, I'm going to look for my highest point. I look like 17. And then my lowest point, which is going to be, looks like 10. And exactly between those two is going to be our midline. I'm going to build my graph as a cosine graph. So I'm going to do something cosine. And then we got x minus something, and then we got plus 13.5. Okay, let's find the amplitude next. And to find the amplitude, I'm going to look at how to get from the lowest point to the midline, or the midline to the highest point, which is going to be 3.5. That's my value out front. All right, let's talk about the period. I'm going to talk about that as the length of time to go from either the bottom to the bottom, which is from 10 to 10 for the y's, and that will take between 4 and 16, so that's going to be 12. And just to make sure that that's the same going from top to top, by the way, it will be, as long as our function's actually periodic and can be modeled with a sine or cosine graph, then we're okay. Okay, going from 17 to 17 is also going to be 12. So if our period is 12, then we can take a look at our b value and call that 2 pi over 12. And then finally, for my phase shift value, I'm going to be talking about a cosine function. So I'm looking for an x value where my cosine starts. And cosine cycles start at the top. So we're starting at a height of 17, and that's going to be an x value of 10. So you've got an x value of 10. For number 21, we're looking at a male penguin's weight over the course of a year. And we're told that at the 4th month of the year, male penguins are at the peak of their weight, and 84 pounds. So I'm going to call that point 4 and then 84. All right, at the end of their breeding season, let's pretend it's in October, okay, which is the 10th month of the year, and they've averaged 51 pounds at that point. So we're talking about this as a max and a min, and I bet if we were to keep going that we would end up back at the max again, because this can be modeled with a cosine equation or a sine equation. And what I noticed is that it takes 6 months to go from April to October, and then if I were to go back to April, it would be another 6 months. So if I wanted to keep this going, 16 months would end up being the next April, because there are 12 months plus 4 more gives me April, and that would get us back to a max of 84. All right, let's make an equation. So again, I'm going to use cosine because it's a little bit easier to work with, because it's based on a max or min instead of on some kind of a midline point. To find the midline first, I'm going to take a look at the average of my max and my min. What's exactly between those two y values? And 84 plus 51 is going to be 135, which gives us a max of 67.5. Sorry, a midline of 67.5. All right, to get the amplitude, I'm going to look at my min to midline, and that's going to be 16.5. And then I need to think about my period, because we're talking about over the course of a year. We're looking at a period of 12 months, 2 pi over 12. And then finally, we're going to do x minus the x value for the max, which is 4. And that'll give us something to map our penguin weight with. All right, here we were given a function, and we have to do some transformations to this. I noticed that I have one x transformation, which is that this entire thing, x minus 4, is going to tell us this is going right 4 units. If I wanted to do this with a table, which is not a terrible idea, I might find an old version of this. So we got old x and old y. And the old x, the first point is at, I don't know, it looks like 1, 3. The top of that semicircle is going to be at 0, 4. And then we've got the other bottom part is at negative 1, 3. Now we're at 1, 3. And then we've got the end of this horizontal segment, which is at 3, 3. So if all of my x values are shifting right 4, I'm going to be at 3, 4, 5, and 3 right 4 is going to be 7. Okay, my y values, I'm going to multiply y times negative 2. That's going to be a vertical flip, as well as a scale factor of 2. And then it's also going to go up 1. So if we think about this as times negative 2 and then plus 1, we have to do the times negative 2 first because of order of operations. 3 times negative 2 is negative 6, plus 1 would be negative 5. 4 times negative 2 is negative 8, plus 1 is negative 7. We already did 3, and it's nice because we have some more points that are there. And we end up at these values. So we got 7, negative 5. 7, negative 5 is here. We have to move up a little bit. We're going to be at 5, negative 5. 5, negative 5 is here. We're going to be at 4, negative 7. So that's 4, negative 7. And then 3 back to negative 5. To kind of keep this going in the same shape, we've got the nice curvy part here. And this, you might notice that this is twice as tall as it was originally. It's flipped upside down from where it was, and it is also moved 4 units to the right. All right, here we've got the graph z of x, and we're asked to find 3z of x plus 1 minus 3. Let's do the same thing. We're going to find some old points and then transform them. So let's just put these guys down. So we've got, that's going to be at negative 3, negative 3. The next part of our zigzag is going to be at 1, 1. That's nice. And then we're going to be at 2, negative 2. And then finally, we're going to be at 6, comma 2. Okay, let's look at my horizontal stuff first. That's the inside. X plus 1 means that we're going left 1. So my points would become negative 4, 0, 1, and 5. My y values are going to be multiplied times 3 and then minus 3. So if this was left 1, this was our y's are times 3 and then down 3. So this would be a vertical stretch by a factor of 3 and then move to down 3. So negative 3 times 3 would be negative 9. Down 3 would be negative 12. Then we've got 1 times 3 is 3, and then down 3 would be 0. We've got negative 2 times 3 is negative 6, and then down 3 is negative 9. And then 2 times 3 is 6, and then down 3 is 3. So we've got 5, 3. We've got 1, negative 9. So that's going to be this ziggy part. We've got 0, 0. That's going to go back up there. And then we've got negative 4, negative 12, which would really be down here, giving us this graph. And again, the transformations are a vertical stretch by a factor of 3, down 3, and left 1. For number 24, we're given an equation. We've got to sketch a graph of the mother function and then the transformed function. I notice this is 2 times the square root of x minus 4 plus 1. That means that our mother function would be y equals the square root of x. I'm going to choose some points that make sense to use for square roots. My first one would be 0. I can't use negative numbers. That gives me an imaginary solution. And the square root of 0 is 0. I'm going to use 1. The square root of 1 is 1. I'm going to use 2, no, 3, no, 4. Square root of 4 is 2, and then nothing works up until 9. I could also do 16, but we're going to see that we run out of room on our graph very quickly. So the mother function here is going to be 0, 1, 2 is going to come from 4, and then 3 is going to come from 9. A nice curve like this. By the way, the domain for this is going to be x is greater than or equal to 0, and the range for this is going to be y is greater than or equal to 0. If you'd prefer, you can do this in interval notation, going from 0 to infinity, and going from 0 to infinity again. Or if you'd like, you can do this in words. Both the domain and range are all positive real numbers. All right, the transformed function, I'm going to build my table. It's going to go for x minus 4. That's going to be right 4. So my new points would be 4, 5, 8, 9 would end up being 13, which is not going to be a number I can use for my graph. So I'm going to just do 4, 5, and 8. Okay, my y values, that's a vertical stretch times a factor of 2, and then up 1. So let's call this y times 2, and then plus 1. 0 times 2 is 0, plus 1 is 1. 1 times 2 is 2, plus 1 is 3. And then 2 times 2 is 4, plus 1 is 5. Let's graph those new points. 4, comma 1 is going to be here. 5, comma 3, and then 8, comma 5. So we'd be starting here and going like this. My domain here would be that we're going from 4 to infinity, and then my range would be that we're going from 1 to infinity. Here we've got -3 times the quantity 1 over x plus 1 minus 2. Got a lot of different things going on here. The first thing I need to do is to identify what my mother function is. And if I've got 1 over stuff, this is going to be y is equal to 1 over x, which I think we called q of x. There are a couple things I need to know about this rational function. The first is that the mother function itself, I'll do this in red, is going to have a vertical asymptote at 0 and a horizontal asymptote at 0. That's going to help us make some sense of this graph. So if I do my usual points, let's go -2, -0.5, -1, -1, 0 is going to give me undefined, which is why we have that asymptote there. 1 is going to give me 1. 2 would give me a half. Based on this and the shape of our graph that we're building, we should know this graph looks something like this. If you'd like to do a couple of extra points, that's fine too. All right, let's transform the heck out of this thing. So we've got x plus 1. That means that my graph is going to go left 1. And then I'm going to do -3 times and then -2. So that's a vertical stretch of -3. We're also going to be flipping this thing, and we're going to be going down 2. So let's call this y times -3, and then -2. I'm also going to jump back for a second and do the domain and range for the parent function or the mother function. Because we have an asymptote here, the domain is going to go from -infinity to 0, and then start again at 0 and go to infinity. What this means with the parentheses instead of brackets is that we're skipping over 0 and we're using every other number. We could also say this is all reals except that x cannot equal 0. That would be okay too. The range here would actually be the same thing because we have a horizontal asymptote at 0. So we're talking about from -infinity to 0. And I'm going to use the more formal notation in union with 0 to infinity. And then if you'd prefer, you can say y does not equal 0, and this would be all real numbers otherwise. You could also say in words, all numbers except 0. All right, let's plot some points. If we're going left 1, that's going to be -3, -2, -1, 0, and 1. I also want to be really careful because I just made an x value for an answer we know is undefined. Which, hey, that's a really good idea for us to put an asymptote in. So the number that would cause us to divide by 0 is causing us to have an asymptote there. I like it. Okay, then let's do some y values. So we have times -3 and then -2. So if we've got -0.5 times -3 is positive 1.5, minus 2 is going to be -0.5. -2 times -3 is going to be positive 8, and then -2 would be positive 6. We've got our undefined point. If we plug 0 in, we end up looking at what used to be a 1 value, so 1 times -3 is -3, -2 is -5, and then we're going to have, finally, a half times -3 is going to be -1.5, -2 is -3.5. The other thing that I want to take a look at is my y equals 0 horizontal asymptote, which if I do the same transformation here, times -3 and -2 is going to give us an asymptote at y equals -2. So I'm going to graph that first, just to help me understand the shape of this graph. Let's do this one in purple. So -3, -0.5. we're going to be right about there. Then we've got negative 2, comma 6, negative 2, and then 6. You might recognize this graph is going to look something like this. All right, on the other side of this, we've got 0, negative 5. And then we've got 1, negative 3.5. 1, 2, 3.5. That gives us me completely ignoring the asymptote, as I undo with the line I just drew, a graph that looks more like this. It also gives me a chance to realize that this should not be 6, but 4 instead, because negative 2 times negative 3 is 6, but then we get a minus 2. And that's totally not accurate either. Negative 1 times negative 3 is 3, minus 2 is 1. Woo, that was fun, and makes more sense based on our other side. That's what we call doing math, friends. The domain range for the new graph, I'll do it in pink. The domain, now our asymptote is at negative 1. It would be all real numbers except that x cannot equal negative 1. And the range, now we have a horizontal asymptote at negative 2, would be all real numbers except that y cannot equal negative 2. I want to use a variety of different ways to write domain and range in case you preferred one or the other.